So my name is Aubrey Chipman. This is my teammate, Roberto Perez, Alcolea, and we're both on the JVM ecosystem team and part of developer productivity and platform overall at Netflix. And today we're going to be talking about transforming dependency update timelines from lag to lightning. And with that, take it away, Roberto.
Yeah, well, super excited to be here again. It's the 4th year, maybe. People will start getting tired of our faces, but I really enjoy it. Thanks for coming. So, of course, spoiler alert, this is not an AI talk, even though there will be a lot of slides created with AI, but we're going to focus on dependency management. So, historically, Netflix went from the monorepo in on-premise to the cloud using microservices. And we created this micro multi-repository world where people will have services and probably some clients or libraries that they will distribute to connect these services between each other. So basically, we build an eventually consistent distributed monolith. And over the years, this has grown, and we will go through some of these examples on how we got here. But in reality, it's 2025, right? And everybody's talking about AI, everybody's talking about how to do things faster and better. So why talk about dependency management right now? Well, turns out this hasn't changed. Dependency conflicts still exist. This increases time for troubleshooting. It reduces the quality of the software. We engineers need to deal with inconsistencies and conflicts. And of course, this lowers innovation because this is what are we getting paid for, really. Innovate and deliver products. And at the end, this will increase the cost not only of software maintenance, but also for a company overall. And of course, the more dependencies, the more libraries we need, well, developers will continue struggling to get these versions out there. So it becomes a real bottleneck. So many people talk about AI. Hans talked about it this morning, where there might be the moment where we will create more and more software, but that means we also need to adopt that software. So this bottleneck becomes even more crucial to the whole developer experience. And tech debt starts accumulating. So to recap a bit here, the slow dependency adoption really impacts the developer lifecycle, the development. So we are going to be slow in adopting this, lagging behind, and there are many things that will happen out of this. First of all, we are going to accumulate outdated code. We are going to have that tech debt. Security risks are always around the corner. Hopefully, we don't get the next Log4Shell, but eventually will happen something similar. There's going to be a lot of missed opportunities because teams will be super focused on fixing these issues that they cannot improve other aspects of their product offering. And of course, continue to increase the cost of this. And Netflix is not immune to that. And we have been investing on this for multiple years. And from now on, we're going to focus in the Java ecosystem because that's what Aubrey and I work on a daily basis. But this applies to many other platforms, Python, JavaScript, you name it. People have to integrate binaries on a daily basis at Netflix. To give a perspective, today, if you're a Java engineer at Netflix, you probably will know that there are more than 3,000 applications running out there in production. We have more than 12,000 libraries that are getting used in production at any given single time. And that includes internal plus open source things. We have 5,000 repositories that are active development, and we have more than 1,000 Java engineers. And when we talk about libraries and the distribution of these modules, what we have learned is that close to 70% of these modules of the 12,000 libraries that we have out there are running with 5 or less versions in production. That means if you have a library like Google Guava, we only have up to 5 versions at any given time across the ecosystem. But we still have a lot of those modules that have more than 10 or even more than 100. And this is one of the biggest problems that we suffer from, because when we want to modernize the stack, well, surprise, surprise, these libraries in the 1.4% or the 12% can probably be holding the whole ecosystem from being modernized. So how do we manage dependencies of Netflix? We have discussed 5 foundations. And the DNA is not something that we copy from this morning's keynote. Turns out it was a coincidence. But we are thinking about this from 5 major aspects: build opinions, artifact observability, distributed refactoring, continuous delivery, and testing and validation. So for the next 25, 30 minutes, we are going to go through these 5 aspects and probably share a little bit more on what we have done at Netflix.
All right, that brings us to our build opinions. And this is going to be things like providing guardrails, guidelines, providing a paved path is what we like to call it over at Netflix, that says, here's an approach that you can take where things are going to go well for you. And there's good setups over in this section. So there's going to be a few different areas that we're going to be talking about first. One of them is about a custom Gradle wrapper. It's a custom Gradle distribution that we have. You can see the Gradle logo over here and our Nebula logo over here. That's our custom Gradle distribution, and we'll be calling it Nebula from here on out. You'll be able to recognize those photos throughout our talk. So another aspect is having build file linting overall. This is where we want to make sure that everyone's using a DSL that's up to date with the current Gradle version, that we have a minimum version of plugins that are being used for this repository, that people are using that people are not having old APIs inside of their build file that are antiquated or just not working with new features like configuration caching or are too eagerly resolving different items. We're also going to take a look at resolution rules. So this is something that we're going to dive into in just a minute, so I'll come back to there. And we also rely on dependency locking. So this is what lets you know that the dependencies that you're using to build your project right now, they're going to be the same ones that you're using to build your project an hour from now, later on. And whenever you do want to update your dependencies, it's going to be an intentional item. That way you can have build reproducibility. So let's take a look at what this is like in practice. Here is how engineers might be consuming different libraries internally at Netflix. We have 4 dependencies up here. These are direct dependencies that you have in your build file. The first 3 are going to be internal libraries. So we see things like com.netflix internal, Spring Boot Netflix, resolving and requesting at latest.release. The other 2 internal dependencies we're also requesting at latest.release. This is saying that it's a dynamic version range. Give me the latest and greatest, the thing that has been tested, that's out there. I want to always be using the latest versions. The 4th item that we have here is a OSS dependency. And so we say, please use major.plus for this. This is something that's going to really help us not have breaking dependency versions, because we have the major version get upgraded as soon as there's a breaking change inside of there. If there's ever something that happens like that internal to Netflix, then we can go reach out to the team individually and say, hey, you broke something. Did you intend to do that for these users? Let's handle this a perhaps different way. But they're folks that we can reach out to more easily, so we just consume them at latest.release. And so consuming them is easy. We just put them in the build file and everything works, right? Well, unfortunately, we have found that is not quite the case. A lot of the things that we're consuming at latest release are from applications that just have rolling version upgrades. So ideally, there's not breaking changes in there, but sometimes there are, and it's not indicated by semver. Similarly, OSS libraries, though they try their best, sometimes do release breaking changes within a minor or patch version on occasion. So there's other things that we want to do as well, and let's get into that. Here's an example software package dependency diagram. So here we have our application, and there's 3 direct dependencies that we're going to be paying attention to. It is this foobar client, awesome client, and Guava 30.0. So in this case, someone added Guava 30.0 as a direct dependency. Probably they need it on their compiled class path, also need it on the runtime class path. But if we notice over to the side, there's some transitive dependencies getting brought in as well. Foobar client brings in Guava 29.0. Awesome client brings in Guava 33.4.4. Well, that's a lot of Guavas. So by the time that we're having our jar file and our application, there's only going to be one version that gets selected. So there's going to be dependency resolution. Go ahead and choose a version via constraints, different kinds of things involved in that. But once we do get a version that we want to use, we want to keep using that particular version. And that's where we use dependency locking. This is one of the things I was talking about earlier. And we want to make sure that we're using this one version that has been resolved until we're actually ready to move onwards. And this is what it looks like in practice. Here's a very small example. We chose org.project.lombok.lombok. You can see that there's 4 top-level listings up here. So each one of these is for a particular configuration in the builds. Lombok is an annotation processor, so we see it on the annotation processor configuration, as well as on the compiled class path to help out with that. If you have dependencies that you need at compilation time, as well as on your runtime class path, then there's going to be more entries inside of this JSON file. But in this case, we wanted to have a small example that fit on a slide. So we chose an annotation processor. So that is all well and good, but what about the transitive dependencies? What about those versions of Guava that were appearing in there? Well, we could address how to have a particular version get selected by maybe polluting our builds, by adding in a configurations.all block, say, hey, force it to this particular Guava version. It is the version I want to use from here on out until I update my build file. But that gets really noisy in everyone's build files. And it gets crufty and aged, and it does not age well. Ages like milk, not like wine. We could also distribute this opinion via plugins, and that's something that we'll do for various other kinds of opinions. But sometimes, especially when we're resolving different kinds of dependencies, it can get tricky to have that actionability of where did this come from? Who introduced this opinion? When did it even get there? So instead, we introduced a resolution rules plugin. And this is something that is a plugin, but the actual items that say what is going to get updated, what's going to get selected, that's something that we version as well. So let's take a look. Oh, also I wanted to say on this previous slide that there are 5 items that we have inside of this resolution rules plugin, and we're going to take a look at the 3 most common uses today. So overall, resolution rules, we go ahead and can modify direct and transitive dependencies at resolution time. We use this a ton internally at Netflix, and it is wildly useful. So in this case, we have our code. There's 2 direct dependencies, these A and B, and all of those other transitive dependencies that get brought in. So the very first type of resolution rule we're going to look at today is substitution rules. And in this case, we have com.netflix.a, that's our group and artifact name. Version 1.2.0 is the first one that introduced some issue of some sort. And the issue persisted in 1.3.0 as well as 1.4.0. Finally, in 1.5.0, it gets fixed. And then the rest of the versions that get released also have that fix in place. So let's take a look at this dependency in action. In this case, our code has a direct dependency on version 1.2.0. Uh-oh, it's affected by that issue. What about this case? Well, some transitive dependency has that it's bringing in com.netflix.a 1.4.0. It's still in that affected version. And so we want to have a solution that's going to address both of these at the same time. So what we can do is define in a handy little JSON file and say, take a look at this version range. I want to address things that are com.netflix:(a) from the range 1.2.0 to 1.5.0. If you see it in the dependency graph anywhere, direct, transitive, don't care where it is, just substitute it towards this one known good version. We're having it as the minimum version that has the fix in place. You can adjust it to any other ones as well, but we typically have it as the minimum version of the good version you'd like to use. Another component of resolution rules is something we call replacement. So this is also very useful. Used it a little bit less, but it really helps out. So this is going to be where we're replacing a dependency at resolution time when both dependencies are provided. In this particular use case, we have ASM, that's the group and name. And then in version 4.0 and later, ASM renamed their group to org ow2.asm. And so we can say, hey, if both of these are on here, they provide the same classes. It's going to cause a lot of confusion. And instead, we just want to have one of them. So if you have both on the class path, just choose one, and we can select which one it is. Another scenario where we use this is having an open source dependency like gRPC API. And internally, we might be using something like the Gradle shadow plugin that goes ahead, grabs that artifact, takes a look at its dependencies, says, that's nice, but in fact, we want to shade and relocate some of these dependencies because they conflict with some stuff inside of the Netflix ecosystem. So we repackage it up, release it as something like com.netflix.io gRPC API. And at that point, you can use either one that you would like. It is perfectly fine. But if both are on the class path, then we're going to eject one of them out of it. And this can happen in this sort of example, where A brings in the internally shaded and relocated package. B might rely on the OSS dependency itself. And then we can define inside of the replacement rule that if both of them are both on there, go ahead, grab one, replace it with the other. So this is a rule that's only going to go into effect some of the time. The third main rule that we end up using is something called alignment rules. And this one is also really excellent. You might be familiar with a BOM or a bill of materials. This is something that we can use to manage and synchronize dependency versions. You might be familiar with things like a Jackson BOM or a OK HTTP type BOM, OKIO. And a lot of open source libraries will list, hey, we put out all of these libraries together. Please use this one version if you use 2 or more of the same libraries. But there's still a lot of projects that don't do that. Or maybe you depend on one of the libraries and a second one gets in there. and you didn't bring the BOM into your dependency graph. So that's unfortunate. And we address this by making resolution rules, alignment rules. We can say, for these items that match this particular group, and maybe this selected dependency versions, go ahead and align everything that's inside of there, because we want to use them all the same version. So we can use this for open source components as well as internal ones, where we're less likely to create our own internal BOM for those items. And let's take a look at the mechanisms of how we do this. I was talking about different JSON files earlier, and we can take a look at what this might be. We have, in this case, substitute com.netflix a JSON. So well named, this is exactly the thing that we're going to be substituting. And we can have a pile of substitution rules, replacement rules, alignment rules that are all going to get packaged up in a jar together. At that point, once we have the jar, we can use Nebula, which is going to be including this resolution rules jar, our resolution rules plugin to translate all those JSON file entries into the Gradle DSL to do things like dependency substitution or other DSL mechanisms. We also want to make sure that when we're releasing this, we're not going to cause more trouble than we're trying to solve. So we can do this by making sure that we're updating this jar in everyone's projects at the same time as we're updating all the rest of their dependencies. We roll this out to the entire suite of all of those different projects, those 5,000 repositories that Roberto was talking about, and make sure that we apply its opinions at that particular time. And we do all of this, as mentioned, through the custom Gradle distribution. So this text file up here, you might be familiar with. It's the Gradle wrapper.properties. There's a particular line, the distribution URL, and normally this points to the Gradle version that you have. In this case, it just points to the Nebula version that we have. But everything else looks the same for our internal developers, so it's a very familiar system of using OSS Gradle to using our internal Nebula distribution. For the distribution itself, as well as resolution rules, we have various validations we want to perform as well. So how do we know if this particular version is valid? We're going to be running an acceptance test. This is something where we go ahead and check out all of the repositories and do a few different baseline builds. We want to make sure that things are buildable off of the main branch. So we do things like, can this project be configured? If so, let's go to the next phase. Can this project be built? Can we assemble our classes, assemble our jars? If so, let's go to the next phase. Can we apply our linting updates? Make sure that people are using the latest and greatest DSL, making sure that people are using plugin versions that are going to be compatible with whatever we're checking it against. And then at that point, we can go apply our new Nebula wrapper version, apply our new resolution rules version, and see, can I again configure the project? Can I again build the project, build all the class files, build all the archives inside of there? At this point, we have a lovely list of how all of these tests go that are broken into different categories. Very helpful UI there, but it is actually terrifically useful. So at the very bottom, we can see things that have all succeeded. It's just alphabetized, so it happens to be at the bottom. We also break things up into things like, this is incompatible with our new version of Nebula. This failed at Gradle configuration time. This failed at our lint fixing time. This failed because it just crashed. And so we might need to look into it later. So because we're checking out all of those active repositories, all those 5,000 repositories, we're going to have items that fall into each of these categories. And we need to go through and find out which ones failed due to our changes versus which ones failed due to, maybe it was red on main. Maybe there was an odd infrastructure issue. So we go take a look at those as well. And as long as most of them are passing, we have a pretty good indication that this release is good to go. So we've been talking about consuming libraries, having them as direct dependencies, having them as transitive dependencies. If that is hard, then at least publishing is going to be easier, right? Alas, not really. There's still questions inside of here as well. So there are going to be things like, who is using this dependency? How is it being used? Will I break? Who will I break? There's going to be a lot more about artifact observability that we really need to be tracking down with data. And this is where I hand it over to Roberto.
Thank you. Yeah, so, well, that was really refreshing and going through all the dependency machinery that we have. For context, all the dependency management features that you have seen here are probably worth years of effort, like 5 more years working closely with Gradle as well. But as Aubrey mentioned, like publishing is hard. Like we got really good at solving dependency management problems, like how can we select the right version for you? But at some point, people running applications or even library owners were asking, okay, which version am I actually using in production? Like, I have a log file, and this is nice. It's built with that. But does it even match what I have running? Maybe. That was the answer. So we built something called Astrid. And you can think of Astrid as a massive index of the dependency graph at Netflix. The way we do it is we try to identify vulnerabilities or any potential issue with each one of the versions that we are aware of. Again, this is internal and open source libraries. And what we try to do is we keep in memory every single version of a given module that is used at Netflix at any given single time. So we are able to answer the question, if I have a library like Wava, how many applications and server groups are using this particular version right now? And the way it works is, when we create a new library, when we produce a jar, we grab the metadata, and the metadata is actually the dependency graph. We rebuild it to make sure that you are actually building against that particular version. And we push that dependency graph to a centralized service, Astrid in this case. Similarly, in order to map things, we started scanning Debian packages. We started scanning EC2 instances and Docker containers running on Titus, which is our orchestration engine on top of Kubernetes. So this is the way that we can understand, okay, this application is running with this base layer of operating system that happens to run this package that has an application and has all these jars. And we index all of that to the point that we can provide in a nice UI on a Spinnaker to people how a single library is getting used. Now, we continue in the example of Wava because it's a really popular library in the Netflix ecosystem. But we can see that the latest version, which is 33.4.8, only close to 6.5% has adopted that in production. And the remaining 93.4% is using an old version of Wava. If we were wanting to move people to the newer version, now we get some sense on who is using what. But also, more importantly, it's not only about what it's running right now. Things that we want to measure is understanding the adoption of a given library. So here you can see the adoption delay, which is the time it takes for a given module version to make it to the ecosystem. These versions belong to our internal wrapper of Spring Boot. We call it Spring Boot Netflix because naming is hard. And you can see that these days, when there is a new patch version of this framework, people start getting it within 3 days. So in the first 3 days, you will have more than 1,500 applications running with this version in production already. But more importantly, when we see things that last for longer, like they take like 3 to 7 days, 1 to 2 weeks, or beyond, we can correlate this data with the stickiness. So we can also understand for how long a version has been living in production. So similarly, we can tell that the version 3.5.33 has been in close to 500 applications, probably to 50, running for 2 to 4 weeks. And this is probably 2-3 weeks old because we try to release on a weekly basis this framework. So at this point, you start wondering, what can be wrong? And then we start looking into all our machinery to give dependencies to people, or what could be holding these folks back from getting the latest and greatest. So these two aspects are really critical for us to understand the adoption of a particular library. And this is how we could answer the first the pie chart that we show at the beginning, which is, okay, with this Astrid indexing, we can understand that 69% of those 12,000 libraries have less than 5 versions in production. And we can continue focusing in the ones that have more than that. So we talk about dependency management, selecting things for people. We talk about active app visibility. But we didn't touch on how do we ask developers to update these log files? How do we ask developers to keep up to date? The reality is that if we ask them to do it manually, they're not going to do it. It just doesn't scale. So we decided to start automating things a few years ago on what people now call distributed refactoring. So people have access, Netflix engineers have access to 4 major ways of getting changes at this point. One is nightly updates. Every night we're able to deliver certain kind of changes, including dependency updates. We can also upgrade a particular dependency if necessary on demand. We have campaigns to run migrations. Think about like going from a Spring Boot 3 to 4, or incident campaigns, as the name suggests, when something goes wrong or there is a security vulnerability, we can find ways to start tackling those. So we will go through each one of those in the next few minutes. But the first one is nightly releases. So for that, we created something called Rocket. And Rocket is basically an abstraction on top of Jenkins, another set of services like GitHub, that allows people to subscribe to certain changes overnight. So people that are in the Java space can request dependency updates, Gradle upgrades, or linting on their build files on a nightly basis or when a new version of the wrapper is released. And basically what this tool does is it clones all the repos overnight in some container, creates a fork out of it, opens a pull request with a change, gets delivered, auto-merge if test pass, and we move on. So this is how it looks for a user. For a user, it's just like every night they will get this managed source dependency log update. It will be a pull request with fresh dependencies, all of them. If all of them changes, we just deliver this massive change to them. The quality gate here is if you have enough tests and they are green, this is what we take as the next step, and this is good to go and good to release. And then if something goes wrong, we send them some nudges over time to say, hey, we have noticed that there are issues here. You should probably talk to us. Of course, there are many opportunities in this area to improve the troubleshooting, but also fixing that for people. But not everything can be delivered overnight, right? As I said, there are incidents. There is necessity for migrations. You don't want people to deliver a pull request and auto-merge that migrate your project to a new technology. So we created a campaign tooling. So we run campaigns. And really, campaigns is just the aspect of rolling out a new technology across the ecosystem. It can be from code to configuration to infra for people. We just try to embrace all of these into the same machinery. And the way it works is we have engineers creating these migration tools or creating these campaigns. And their work is to identify who they want to target. So they need to understand their audience first. And they will provide certain things like manual paths. Do they need to go and do the things manually? Can they get automation? Will they get a pull request? Each campaign will have different things based on the maturity of our tooling. And we have three types of them, the three bigger types: migration, incident, and vulnerability. But at the very end, the experience is similar for all of them. You can see an example of the future campaign of JDK 25, and we already have people adopting that. Thanks to one of our coworkers here, that he's doing a phenomenal job on doing this. But also, you can see things like open pull requests to upgrade JDK applications. Now, this is very powerful because we were stagnant in Java 8 for years. And when we started investing in this tooling, now we are able to get most of the fleet, when we run this campaign, in probably between 70 to 80% of the applications in the latest and greatest JDK just within weeks. To give a concrete example, I think at this point we are close to 70% of the fleet using Java 21. Probably 90-something% remains on Java 17. But we don't say Java 8 anymore, only for a few pockets that really require to be in older versions. But I'm pretty sure that you have been in situations when you automate pull requests for people, and opening pull requests or merging them is not enough. They sit there forever, but imagine the world where they get merged. The reality is that the work is not done until it's delivered. Like, it doesn't matter if you merge a pull request, gets built, and published if the application or the library is not getting used. So we continue investing on continuous delivery here. Surprise. So what we noticed is, by talking to people, is they didn't feel confident receiving changes from other teams. They were doing ad hoc releases and manual releases. So in theory, we were not actually practicing continuous delivery, if you think about it. We had the tooling. It's like you have Jenkins, you have CI, you have the Spinnaker, you have continuous delivery. But the practice itself was not good. So we started looking deeper into this. And we came up with this program called Increased Confidence and Frequency of Deployments. We talked about this last year in more depth. So if you attended, this is just going to be a small portion of it with the results. If not, you can watch the video online. Shameless plug. But basically, this is where we were last year. In the middle of almost end of 2024, we found that people didn't feel comfortable getting changes from other teams' automation. But also, they were doing more than 50%, close to 60% of deployments happen either monthly or ad hoc. So that was really terrible. So we reused the tooling. Let's do campaigns. And in this case, the campaign was targeted to help people achieve more confidence and frequency of these deployments by providing guidance, tools, etc. So there was a lot of investments beyond infra. We were also doing some cultural shift here. And this is the important thing. The results of this effort, it was like a 1.5 year long running effort, or going and talk to customers, going and create all the testing tooling they might need, going and create all the training they might want. But what is important here is that if you look at the agreement levels, 53% of people now agrees that they can get changes. 34% strongly agree. So more than 80% of the company or engineers feel okay with receiving automated changes from a platform team. So this is important for us. We have built trust, right? And similarly, we have now 60% deployment, daily deployments, and 26% weekly. So now, even though those weekly could be on a daily basis, going from 50, 60% of manual ad hoc or weekly into 60% daily was a massive win for us, because that means that we could get to this point where it will take a few days to pick up a new version of a given Spring Boot Netflix release. So it's a huge success. But this wouldn't be possible without testing and validation, and Aubrey's going to talk a little bit about it.
Excellent, thank you. So yes, the testing and validation components are a critical aspect to making sure that this is going to be successful, because it's not just we tell our engineers who are working at Netflix, believe in our platform changes, they're going to be wonderful for you. But we needed to provide ways that they can actually take it to heart and see that the changes that we're providing, they're well tested, they are well validated. And how do we make sure that we bridge that gap? This is something that we were doing this last year and a half with several different teams. So one of them was taking a look at just our recommendations overall. We did a big overhaul to make sure that our testing documentation, project setup documentation, how to connect to this internal database, how to use this particular data structure, they're all housed much more closely together, and we can provide recommendations about it overall. So this improved our CSAT, and people were really happy to have a guidance for how to use these internal Netflix components, which are slightly different than the OSS versions of them. Another aspect is we want to provide insights about testing overall. So typically, we have a lot of data. We have lots and lots of data, especially that exposed in Develocity. But we wanted to highlight some specific aspects, some just key critical components where we wanted people to focus on. So these are going to be things like, what does your test success rate look like on the mainline branch? This is after you've made a pull request. Typically, you've gone through that validation. You merge it back into main. How's it going? What does your test execution time look like? So how quickly can you get that feedback loop completed if you're building locally or building in CI? As well as, what does the code coverage % look like? So this is going to give us indications of things like, if there's 0 code coverage on this repository, there is likely going to be a problem, for example. So all of that was taking a look at either one repository, one application, one software type. But we can also see this in aggregate, and this is going to be really useful. So this is a view that I might see or my manager might see, and each particular row is going to be a software component. It's either an application, a repository, a library, this kind of thing. And it's having those same sort of metrics visible on here with indication if it's going up or going down. What does it look like by percentage? And it really just lets us have an overview of the things that are important to me, what would be useful in this testing insights viewpoint. This also rolls up along the organization chart. So my manager has a similar view. My manager's manager has more things that are owned by that organization structure, and it continues all the way up to the top. Another aspect is we wanted to have a highest level overview, like at a glance, how are all my things doing? I just need to know, like, are they doing fantastically, or do they really need some assistance? So we have a scorecard over here, and these are going to have different levels that you can just see at a glance. It lets you know, in the testing area, are you doing things along the gold standard of what we're calling it right now? It takes a look at things like your test suite success rate, some information about your test coverage rate. More things can go into here, but it's giving an idea overall of what does it look like right now. Other levels might be things like you're doing a silver, you're doing bronze, or you are stuck in the Stone Age, you got some work to do. So in addition to making sure that that information is visible for folks, we want to improve the testing developer experience. So this is going to be things like using Develocity's remote test distribution. This is going to give you automatic parallel distribution of your tests. You send out the class files, send out the jars, send them to running agents, and then you're able to stream the results back and the logs back as well. This lets you have parallelization because you're not just running all the things on your one machine and running into resource contention, but you can send it out to a fleet of agents doing all this work for you. It's also going to make sure that you have the same consistent experience on your local box as you do on CI. Typically, all of our CI agents or a lot of them are going to be Linux agents, and I typically don't work on a Linux box, so sometimes we run into inconsistencies, and this really helps with that. Another aspect is taking a look at test slices. So we have lots of data that is going to get used in production in various ways. Typically, you might have things that are very resource intensive, very memory intensive. You might need to load a lot of data that says this is test environment like or prod environment like. But when you're going to be running a bunch of tests, especially if they're small unit tests or integrating a couple of components, maybe you don't need all of that data loaded up. So we want to have what we call test slices, which is going to just have that API contract, have that boundary on there, but hold just a little bit of data to look at. This is not where we're doing things like performance optimization, performance validations, but just what does it look like? Can I touch it? Does it work in this particular slice? Have I met that contract? Another area is having to do with JUnit platform test parallelization. So if for some reason you can't send things off to remote test distribution, or you want to have things even more parallelized, you can set this up in your repository. This allows you to have parallelization, but it's going to be run on this one machine if you're not using something like test distribution. So you might still run into performance issues, but it does let you have parallelization and let things run faster on your machine to help close that feedback loop much faster. Another area that we've been investing in is around identity propagation for post-deployment verification. So this is something like you have sent your application to a low-level environment, say a test environment, and you want to make sure that you can run validation steps on there. And typically, you might have done this maybe in a Jenkins job before, this kind of area, but it was kind of a one-off. So we made this something that's very easy for people to opt into, just set up your project in this particular way, and then all of a sudden it happens on every one of your deployments that you can have this post-deployment validation verification test set up. And as well, we've been working in improving canaries. So this is something that Netflix is very well known for, that we have canaries that take a slice of production data, production traffic, and as we're sending things to be ready for production, we can run verification on there and say, is this ready to start receiving all the traffic? We run lots of analysis as this is going out that way. But we're also able to use canaries to take a look at things like campaigns where there might be several commits where we make a big framework change or we are having a big migration change and we really want to get an idea of how's it doing in the performance aspect. So we're able to use that as well. So with this, with everything that you've heard from us on stage today, everything is perfect and our jobs are done, right? Right? Alas, it is not. So we keep investing on this particular experience. So for example, we have seen that the artifact observability that we were talking about with Astrid, it's still not enough, which is unfortunate, but it gives us good things to work on. So right now we're able to see what jar is deployed in any of the environments at any particular point in time, but there's still some amount of incomplete tracking that assumes that you're going to be going through the 90+% use case of deploying through Spinnaker and you have this particular deployment pattern. But if you're taking something like a jar and then running it as a CLI somewhere, we might not be tracking that in the same sort of way. So we want to make sure that we are going to be addressing that. As well, there's various metric system silos where people have done introspection on all the data that's available, but they're in disconnected, disparate areas. So the data is there, but it's kind of hard to put together. And that also goes along to limited visibility. Sometimes that data requires you to be part of a particular team that has access to the data to see what is going on in those zones. And we want to make sure this is easier for people to understand as they're releasing their changes. Who is it really affecting? What is going to be a breaking change down the line? So with this, one of the things our team is taking a look at is investing in method execution detection. And one of the important aspects on here is that it needs to have a low performance impact. So this is something that we might do at build time, might do at runtime, investigating these areas. But overall, we need to make sure that it causes a small load on the system, as well as being able to track these method executions. This might be things like taking a look at the symbols, taking a look at what is actually getting used, what is not getting used in these code paths. We also want to have a central index that is going to hold all of this so that other people can take a look, can query it, can see, hey, if I make this modification, is it actually going to break a bunch of downstream users or just the ones that are also on my team? Let me know. We also want to take a look at the JVM where this is running, as well as if people are using internals, encapsulated items, breaking encapsulation. So let's do a quick recap. Overall, developers can struggle with keeping up to frequent dependency updates. And as we're hearing a lot of things, especially this next couple of days, about AI making us more productive, we have more changes going out, more releases being made. We want to make sure that we keep an eye on how often everyone is keeping up to date with these dependency updates. What does that stickiness look like? What does that adoption time really look like? And the way that we're addressing this over at Netflix is with these foundations of dependency management, having a good paved path for our developers with build opinions, having artifact observability, being able to know where your artifacts are in the runtime ecosystem overall, being able to address distributed refactoring so we can help all of our users move from one system to another, be it build time constraints or taking a look at the actual class files themselves and being able to migrate those. Taking a look at continuous delivery, making sure that we are, in fact, releasing all those code changes and PRs that were being sent over, and having a wonderful approach to testing and validation. That way people are comfortable receiving changes from platform so that we can help move everybody over together. And now we've got a few takeaways. So takeaway number 1, code changes are going to be a part of life. We've got to be adaptable to them, and doing this badly costs toil, money, and friction. And as we heard from Brian earlier today, toil is going to make it much harder to be innovative. So takeaway number 2, there are many people involved in this aspect. So there's things like library owners, library consumers, platform providers. You want to make sure you're hearing from all of these people who are involved in these areas and that we're making it as easy as possible for each of these components, each of these personas. Takeaway number 3 is we want to measure and provide visibility into the areas that are important. Typically, we want to provide 1 to 2 or 3 items that people can say, hey, these are the things that I need to look at. From the context provided, these are things that I can make a measurable impact, can make a measurable difference in the performance of my area, in the stability of my area. So these can be things like version adoption, release cadence, testing insights, whatever you find that is going to really help the folks in your organization to feel more confident and to get better performance, these kinds of items. Takeaway number 4 is that keeping dependencies up to date and releasing these code changes has to be a priority with a cultural focus. So there's lots of items that we hear on how to do things better with tooling, but everything that we've been talking about, as Roberto alluded to, has been many years in the works, many different engineering teams, many organizations coming together and making sure that we have a streamlined pathway, that it's a good paved path approach, tackling from a bunch of different directions. And all of that is a cultural focus, making sure that all of our internal engineers have a good way to keep everything up to date. So thank you very much. Hope you enjoyed. And now we're going to open it up for questions.